There are two driving forces for a reaction. So reactions are either spontaneous or non-spontaneous. Spontaneous means the reaction takes place on its own. Non-spontaneous means we have to help it actually take place. We have to give it a jump start. In order for a reaction to be spontaneous, we have to look at two different driving forces. We have enthalpy, which, remember, enthalpy is heat. And enthalpy, nature likes low heat, so we like low enthalpy. There's an L and an L to help us remember that. Well, if it's a low enthalpy, that means the reaction then tends to be exothermic. So nature likes exothermic reactions. Exothermic reactions tend to be spontaneous, not always, but usually. So what would make them non-spontaneous would also be the entropy. Entropy is the second thing that we have to take into account. Entropy is symbolized by the S, capital S, and it simply means disorder. Nature likes disorder. So nature likes high entropy. Lots of disorder. As we go from the solid to liquid to aqueous to gas, we're increasing our disorder. Our molecules are moving faster. There's more randomness in there. If I look at my first example, I have two solids forming two solids and three gases. So since I'm increasing the amount of gas, I'm increasing my disorder, so delta S is going to be positive, which is a good thing. Nature would like that. In number 2, I'm going from having 3 gases to only having 2 gases, which means I'm decreasing my disorder. Nature doesn't like that. In number 3, even though I don't have any gases here, I'm taking things that are aqueous, things that are floating around in water, and I'm forming solids, which are tightly, closely packed together. So that would be a decrease in disorder. Again, nature would not like that. So with a combination of enthalpy and entropy, we can determine whether or not a reaction is spontaneous or non-spontaneous.